Good day, learners. Now let's talk about triangle inequality. So the triangle inequality theorem states that in any triangle, the sum of the lengths of any two of its sides is greater than the length of the third side. We have here triangle ABC, so that means the measure of side AB plus the measure of side BC should be greater than the measure of side AC. Similarly, the measure of side BC plus the measure of side AC should be greater than the measure of side AB. And the measure of side AC plus the measure of side AB should be greater than the measure of side BC. Okay, so all you need to remember is that the sum of the lengths of any two of its sides should be greater than the length of the remaining side. Let's have an example. Let's determine whether the segments of the given lengths can or cannot be sides of a triangle. Applying the triangle inequality theorem, let's see if 10 centimeters, 9 centimeters, and 5 centimeters can be sides of a triangle. Okay, so first, let's have first the sides 10 and 9 centimeters. So we have here 10 centimeter. Let's add the 2 plus 9 centimeter. According to the theorem, their sum should be greater than the remaining side, which is 5 centimeter. So it's greater than 5 centimeter. 10 centimeter plus 9 centimeter, that's 19 centimeter, is greater than 5 centimeter. Now look at this one. Look at the inequality. Is this true or false? Is 19 centimeters really greater than 5 centimeters? Okay, yes. So meaning to say this statement is true. Okay. Now, let's have 5 and 9. So we have here 9 centimeters plus 5 centimeters should be greater than the remaining side, which is 10 centimeters. So we have 10 centimeters. So add, we have 9 plus 5, that would be 14 centimeters. It's greater than 10 centimeters. So is this statement true or false? Is 14 centimeters greater than 10 centimeters? Okay, true. And lastly, we have 5 and 10. So it's 10 centimeters plus 5 centimeters should be greater than the remaining side here, which is 9. Should be greater than 9 centimeters. 10 plus 5 is 15 centimeter. Is greater than 9 centimeter. So we can see that the statement is true. And since all of our 3 inequality statements here are true, then we can say that 10 centimeters, 9 centimeters, and 5 centimeters can be sides of a triangle. Okay, next, let's have example 2. Let's determine whether the segments of a given length can or cannot be sides of a triangle. So we know already what to do here for applying the triangle inequality theorem. So let's add first 9 and 6. So we have 9 centimeters plus 6 centimeters should be greater than 2 centimeters. So 9 plus 6, that's 15. It's greater than 2. So 15 centimeters is really greater than 2 centimeters. So our statement is true. Next, let's have, this one. So that is 6 centimeter plus 2 centimeters should be greater than the third, which is 9 centimeter. 6 plus 2 centimeters, we have 8 centimeters is greater than 9 centimeters. Now, is this statement true? Is 8 centimeters greater than 9 centimeters? Okay, it's false. So, we'll write false. And let's check the remaining one. Let's have 9 and 2. So 9 centimeters plus 2 centimeters should be greater than 6 centimeters. 9 plus 2 is 11 centimeters. Is greater than 6 centimeters. Now we can see that our statement is true because really 11 centimeters is greater than 6 centimeters. So we'll write here true. But we can see here that one of our statement is false, and this is 8 centimeters is less than 9 centimeters. So we'll say as a conclusion that 9 centimeters, 6 centimeters, and 2 centimeters cannot be sides of a triangle. So all of the statements should be true in order to say that the 3 dimensions can be sides of a triangle. Okay? Next, let's have the third example. 9 centimeters, 6 centimeters, and 6 centimeters. So first, let's have this one. 9 and 6. So we have 9 centimeters plus 6 centimeters is greater than the remaining, which is 6. So that is 6 centimeters. Now 9 plus 6 is 15 centimeters. That's greater than 6 centimeters. So here our statement is true. Next, let's have this one. 6 centimeters plus 6 centimeters is greater than the remaining, which is 9 centimeters. 6 plus 6 is 12, so we have here 12 centimeters is greater than 9 centimeters. 12 centimeters is indeed greater than 9 centimeters, so our statement here is true. And lastly, we have this one. 9 centimeters plus 6 centimeters is greater than the remaining, which is this 6 centimeter. So 9 centimeter plus 6 centimeters is 15 centimeters. So it's greater than 6 centimeters. So our statement here is also true. And since all of our statements here are true, then as a conclusion, we'll say that 9 centimeters, 6 centimeters, and 6 centimeters can be sides of a triangle. Okay? So that's how to determine whether or not the given dimensions can be sides of a triangle. Now let's have our fourth example. The lengths of side AC and side BC in a triangle are 8 centimeters and 11 centimeters respectively. What is the range of values of side AB? So let's try to illustrate our triangle. Okay. Alright. So we have here triangle ABC. Side AC is equal to 8 centimeters. That's according to our given. So that's 8 centimeters. Side BC, 11 centimeters. So what we are looking for here is the range of values for segment AB or for side AB. So according to the triangle inequality theorem, that the sum of the lengths of the two sides of the triangle should always be greater than the third side, we can solve the range of values for the third side using this inequality statement. Side AB is greater than 11 minus 8 but less than 11 plus 8. Okay, where did we get 11 and 8? These are the given dimensions of the two sides of the triangle. Solving, 11 minus 8 is 3 centimeters. 11 plus 8 is 19 centimeters. So segment AB is, the measure of segment AB is greater than 3 centimeters but less than 19 centimeters. So this is already the range of possible values for segment AB. Okay, now let's check if the given range of values is correct. So how do we check? Let's pick one value from the range. So let's say that side AB is equal to 5 centimeters. So let's just say that, okay, picking from the range, we have, let's say that side AB is 5 centimeters. Okay, let's see if 5, 11, and 8 can be dimensions of a triangle. So let's write here so it will be clear. We have 11 centimeter, 8 centimeters, and 5 centimeters. Okay, so first one, segment AC plus segment BC should be greater than 5 centimeters. So that's 8 centimeters plus 11 centimeters is greater than 5 centimeters. Now 19 centimeters is greater than 5 centimeters. So our statement here is true. Next, let's have segment BC plus segment AB, which is we let as 5 centimeters. So that's 11 centimeters plus 5 centimeters is greater than the remaining, which is 8 centimeters. So 16 is greater than 8. So our second statement is also true. And for the third one, we have segment AC plus segment AB. It should be greater than segment BC. So segment AC is 8 plus 5, that's 13. That's greater than 11 centimeters. So our third statement, inequality statement, is also true. So since our inequality statements here are true, then we can say that the range of values for the third side is correct. So this range here, okay, that is correct. Now let's have the side angle inequality theorem. So it states that if one side of a triangle is longer than the second side, then the measure of the angle opposite the longer side is greater than the measure of the angle opposite the shorter side. Okay, so what we have here is triangle ABC, and according to the number of tick marks of our triangle, we see that side AC is longer than side AB. So meaning to say, the angle that is opposite to side AC, which is angle B, is greater than the measure of the angle opposite to the shorter side, which is angle C. Okay, so comparing also angle C and angle A, which is a bigger angle. So let's have, okay, so the side opposite to angle C is longer than the side opposite to angle A. So meaning to say angle A is smaller than angle C. Okay, so that's the side angle inequality theorem. Now let's have the angle side inequality theorem. So it states if one angle of the triangle is larger than the other angle, then the opposite of the larger angle is longer than the side opposite the smaller angle. That means if angle B is greater than angle C, then the side opposite to angle B is longer than the side opposite to angle C. So this side AC, is longer than the side opposite to angle C, which is side AB. Okay, and if angle C is greater than angle A, then the side opposite to angle C is greater than the side opposite to angle A. Okay, and if angle B is greater than angle A, so the side opposite to angle B is greater than the side opposite to angle A. Okay, so basing from our illustration here, we can see that the side opposite to the largest angle is the longest side, and the side opposite to the smallest angle is the shortest side. Okay, let's have examples. So we have here example 1, name the smallest and the largest angle. Here we have triangle ABC. So we are given the number of the dimensions of the side. So let's identify the smallest angle. So smallest angle. Okay, so Applying the theorems that we discussed in the previous slide, the smallest angle is opposite the shortest side of the triangle. So since the shortest side here is side AB, so the angle opposite to side AB is angle C. So meaning to say, angle C is the smallest angle. And the largest angle is the angle opposite the longest side. So here the longest side is side AC, which measures 15 centimeters. So its opposite angle is angle B. So the largest angle is angle B. Okay. Now let's have number 2. Name the shortest side and the longest side of triangle ABC. This time we are given the measures of the angles. Angle C measures 48 degrees, angle A measures 109 degrees, angle B measures 23 degrees. So we know that the shortest side is opposite the smallest angle, and the smallest angle here is angle B, which measures 23 degrees. So our shortest side again is the side opposite the smallest angle, so that is side AC. And our longest side is the side opposite the largest angle, which is angle A, so that is side BC. Okay? And lastly, let's list the angles of triangle XYZ from smallest to largest. So let's arrange from smallest to largest. We are given the dimensions of the triangle. So let's identify first the smallest angle. So the smallest angle is the angle opposite to the shortest side. The shortest side is side XZ. So the smallest angle is angle Y. Next, okay, we have 10 centimeters. So the angle opposite to it, okay, so the middle is angle Z. And the largest angle is the angle opposite to the longest side, which is 13 centimeters. So that is angle X. So from smallest to largest, arranged from smallest to largest, so we have angle Y, angle Z, and angle X.